Hello and welcome to video number 14 for Networks and Data Security. My name is Chris. Now, the primary purpose of this video is simply to show different network diagrams, the symbols and what they mean. We're going to look at a couple different types of network architectures. And I think making this one is probably going to be one of my favorite experiences of all the videos, mostly because I don't have to do anything with myself. I don't have to do my hair or brush my beard or shampoo my neck. I just have to talk and explain what's going on with these different pictures and diagrams and hope for the best. Let's go. Alright, now to start us off with the symbols, I thought the order was going to be different, it doesn't matter. On network diagrams, there are different symbols that are almost a standard when it comes to setting these diagrams up so that the readability is the same basically no matter what language you're reading it. On site and using the pictograms alone, you should be able to determine the general idea behind the structure and setup of this network. The first symbol we're going to look at here is a firewall. The illustration being that of a red brick wall, kind of self-explanatory. Once you see other things and symbols around it, you should probably have a good idea of what that wall represents. Next is the cloud. Now this represents the ethereal cloud of information that exists everywhere at all times out in the internet. Not the internet itself, just that store of data that exists everywhere at once. A terminal, also pretty self-explanatory. This pictogram is used to illustrate a computer in your home or a workstation in a business. Next is the modem itself. This is what would establish and allow communication between, say, terminals and LAN routers and the ISP itself. There is the server pictogram, which is used to illustrate a server in the network architecture. Don't really know how else to put that. There's a router. Now we're going to see a couple of variations on the router pictogram itself, but this is the basic one. The idea being that you, behind your modem, may have a router which is distributing internet connectivity and LAN connectivity to numerous terminals. So in the event that we have, say, 2 or more terminals on a network diagram, you'll typically see a router between them and the modem between them and the ISP. And lastly, signal, which can be illustrated in a few different ways. Sometimes it's just solid lines to indicate a wired connection. It could be the radio waves to indicate wireless connectivity, or the lightning bolt to indicate connection over distance. Now, in a typical home network, you've got something likely set up similar to this. This is also a diagram that could be applied to a small business. Along the bottom and in the right, we have 3 computers, which could also be workstations or terminals, of course. In your home, they would be your personal computers, your laptop. In a business, these would be workstations on desks and what have you. Portable devices like laptops and whatnot as well in a workplace or in your home would apply here. You also see a PDA in the bottom left. So your cell phones, or people don't use beepers anymore, but tablets. Portable mobile devices that could be used in the workplace, just to kind of have some of the data on the go. Also printers. In this particular diagram, however, they're showing it as a 6-port switch, which would indicate a solid wired connection only, wired between the terminals, the PDA, the printer, and the switch itself. Now the switch is the gateway between those devices across the bottom and both the business server and the router. Now, in your home, you probably don't have a server set up. Some people do. Looking at you, Michael. That being said, you wouldn't necessarily have a server set up in your home, but you would definitely have one set up in the business. The end user terminals are going to be segregated and apart from servers. Now, between the end user switch and the server and the ISP, between those devices and the ISP, is always going to be your router or gateway. Now, this will be a combination device of modem router to split the incoming internet connectivity between the end user network, so like the LAN or whatnot, the user network that's set up there, and the server itself. Now, the reason for this is quota, is network isolation. Internet connectivity for the workers and the employees and the managers and whatnot is a necessity. But You also need to ensure that that server has dedicated access out to and back from the internet. This is in the event of backup procedures, or say if your business is working as a hub or a data broker of sorts. That server and the employee networks are typically going to be on isolated networks apart from each other, just to ensure that that server has the bandwidth that it'll require to perform its job. Outside of the motor router combo there is the ISP. So that's whoever the internet service provider is, kind of self-explanatory. And beyond them is the cloud, the internet, and everything else in the world. Large business or enterprise network architecture, we're going to do something a little fun. Now, for the purposes of, say, a large business or enterprise network architecture, we're going to do something a little fun. For starters, this is what's most external to that business enterprise network setup. The internet, the cloud, what have you, and its connection to your internet service provider. And then we give it a quick zip, and whoop, there's the main server. Now, they've indicated that this is Red Hat Enterprise Linux server. Hey, whatever, awesome, that's fine, I don't care. But that server itself is on the outside of a firewall, and it's the first blockade or gateway, but also the primary point of entry between the business enterprise network and the outside world. And then we give it a zip. And then here we have a firewall. Now the distance in between the two is trapped between a firewall at either end. Now internal to the firewall illustrated here is the server structure of this business enterprise network. The small pictogram of a server is actually representative of the setup. So this giant router stack is the primary hub of communication between this large business network and the outside world. Now from this server, the different network interconnectivity, network isolations, all the different terminals and whatnot, it distributes that signal and service down to those servers itself. You could have various different systems and departments, one on each of these different servers. You could have accounts receivable, for payroll and whatnot. You could have the local site databases stored on one or more of these servers. You could have, say, business applications and programming done on one. Each one of these server pictures illustrated here is representative of separate networks that are apart from one another, further broken down to routers and switches, likely potentially firewalls, and then ultimately the end user terminals and devices. Now what does that all mean? It means you can paint pretty pictures of networks to suit the overall general idea of different network scenarios and architectures and setups. What it means is that it's actually very easy to illustrate your idea of the ideal network, or to take an existing network, if you know a little bit about it, and turn that into a picture that's very easy to understand. The whole point behind making these network diagrams is to illustrate for troubleshooting purposes, documentation, and even just like charting. When it comes to the growth of a business and its business need, when it comes to projections for expansion on a network, you would design a network diagram centered around where you're at now or where you need to be to support either your user base or your employee base or the expected bandwidth and data that's being transmitted back and forth. That about sums it up for video number 14 of Networks and Data Security. Again, my name is Chris, and I'm still not wearing pants.